In this question, question number 24 from AICE Physics paper 13 from 2019, October-November test administration, the question read, a siren emits sound of frequency 1000 hertz. The siren moves at 20 meters per second towards an observer who is standing still. The speed of sound in the air is 330 meters per second. Which expression would correctly give, the frequency heard by the observer? Everybody with an equation in mind for the observed frequency, noting the Doppler effect, would say the observed frequency, why that's equal to the frequency of the source times the velocity of the wave over the velocity of the wave plus or minus the velocity of the source. Towards an observer, towards subtract. Okay, towards subtract. So if it's towards, you're always going to subtract in the denominator. That's going to make the observed frequency higher. Okay, and so if we sort of match the given information, there's the frequency of the source, there's the velocity of the source, there's the velocity of the wave. We're trying to get an expression that's going to solve for the observed frequency. So it's this one. So they've plugged in the frequency of the source, the velocity of the wave over the velocity of the wave, and minus, because towards subtract. So choice B has to be correct here. If you were to calculate that, you'd realize that the observer would hear a frequency of about 1065 hertz. And so the way to get a higher frequency than the frequency of the source is to subtract in the denominator. This should always agree with the sort of familiar Doppler effect sound of meow, right? And so when it's moving towards, it's higher pitched. And when it's moving away, that's the meow of meow. And that's the Doppler effect. This has been a work example with Dr. Schleid. See you next time.